So when naming nitriles, we got to recognize that the nitrile itself contains a carbon. So when we're determining the longest carbon chain, we have to keep in mind this carbon from the nitrile group. Sometimes, however, though, when the nitrile is lower priority, that carbon becomes part of the cyano group. So we have to keep that in mind. So if the nitrile is highest priority, we're going to keep the carbon as part of the main chain name. So for example, in this case, I would have a 1 carbon here, a 2 carbon. This would be an ethane. And then what I do is I just put nitrile at the end here, so I don't drop the E. So ethane nitrile. If I were to have a 3 carbon chain, 1, 2, 3, this is a propane, and it is a nitrile as well, and so on and so forth. So I go to a 1, 2, 3, 4 carbon chain, and so now this is a butane nitrile. I think I spelled that right. So now when we add substituents on, we still again recognize the longest carbon chain. So 1, 2, 3, 4. And in this case, the alcohol is lower priority than the nitrile, so it becomes a substituent hanging off the main chain. So in this case, we're going to have a butane nitrile. But in the 4 position is a hydroxy. So out front here, I would have a 4 hydroxy butane nitrile. So again, with naming nitriles, we got to watch out for the hidden carbon. But again, even with the aldehyde too here, we've got to watch and recognize that there's a carbon right here on this aldehyde that needs to be included. The aldehyde is lower priority than the nitrile. We have 4 carbons, so again, this is a butane nitrile. But in the 4 position now is an oxo group. So this becomes an oxo because it's lower priority. So we're adding more examples here. We have a cyano group, or a nitrile group. 1 carbon, 2, 3, 4, 5. Out of all the substituents on here, the nitrile is still highest priority. So the 1 carbon starts with the nitrile. 2 in the 3 position is an alkene. It also has stereochemistry that we have to figure out. And then the 5 position is a chloro. So if we're to work on this, this is a pentane. It becomes a pentane nitrile. We have to now indicate that there's a double bond in it, so it's going to be a pentene nitrile. And out front, there's going to be this 5-chloro. Some things that are missing then is where the position of the double bond is. So that'll be in the 3 position, so I got to insert that into here. The nitrile doesn't need a 1 in front of it because it's the highest priority group, and it's assumed it's on the end. And the other thing is the stereochemistry. So I need a stereochemistry here, so out front we're going to indicate a stereochemistry. So let's figure out the stereochemistry first, and then we're going to rewrite this entire thing. Erase all this. So for the stereochemistry, there's a hydrogen here, hydrogen here. So if you haven't, if you're not familiar with the E and Z naming scheme for IUPAC, please go back and watch my video on that. But essentially, starting from this carbon, there's a carbon here of this double bond. There's a carbon here that's a higher atomic number than this carbon, so a 1 and a 2. And similarly over here, this carbon is higher atomic number than this hydrogen, so a 1 and a 2. The 1s are on opposite sides. They're not on the same side. They're not on the same side, so it is an E conformation. So we're in the 2 position, we're looking for an E conformation. So let's try to continuously write this word, this compound out. So starting, oh, it's in the 3 position. 1, 2, 3. How come no one corrected me? There we go. So in the 3 position, we have that. In the 5 position was that chloro that we spoke of. We know that we have a pent, and then in the 3 position is this ene. I'm going to keep the E because I have an N right afterwards. Nitrile. Like that. And so I don't need a number here for the nitrile because it's assumed that that's the number 1 carbon. So for the nitrile on the top right here, longest carbon chain, 1, 2, 3, 4, 5. But then these are not just all methyl groups, 6. So this is a hexane. What that means then is we have a triple bond on the 3 carbon, the nitriles on the number 1 carbon. But in the 5 carbon, we have a methyl group here and a methyl group here. So we have a dimethyl group. So we know we got a hexane. We know that it becomes hexane nitrile because of the nitrile group. The ane here has to turn into an ine because of the triple bond. So we have a hex ine nitrile. And then out front, I have 2 methyl groups. So 5,5 dimethyl. So the only thing I'm missing then is to indicate where this ine is. And it's in the 3 position. So let me erase this and rewrite this whole system down again. So it's a 5,5 dimethyl hex 3 ine nitrile. All one word. So in this compound on the top right, we'll start off with the longest carbon chain, recognizing that the carbon is part of the nitrile group. So we'll do a 1, 2, 3, 4, 5, 6. So this is a hexane. Sorry, that's a hexane. And in the 1 and 6 position are nitriles. So it's a dinitrile. But we don't have to indicate the 1 and the 6 position because these are the highest priority groups. So I can rewrite this as a hexane dinitrile. That finishes off that naming. So this example is going to be a case where the nitrile is no longer the highest priority functional group. So if I start with the carboxylic acid, 1, 2, 3, 4, I'm going to put a 5 here, but since the cyano group or the nitrile is lower priority, it's going to be called a cyano group. But the cyano group takes the carbon into account. This is part of the actual group hanging off the number 4 carbon. So when the cyano group is lower priority, we have to include the carbon in with the nitrile group, and it no longer becomes part of the longest carbon chain. It's only when it's higher priority. The example over here, this is a acid chloride, and similarly, it is higher priority, so I am also going to include this carbon as the cyano group. And so this is only a 1, 2, 3, 4 carbon chain. This is a butane group. This is a butane group. So we got to keep that in mind when we're dealing with the nitrile as a lower priority group. It becomes a cyano group, and the cyano is a C triple bond N. That C triple bond N is 1 unit, and it is not part of the longest carbon chain. So let's erase this and keep going to actually name it. So then I would indicate 1, 2, 3, 4. The cyano is now in the 4 position. So this is a butanoic acid. There is a space here. And in the 4 position now is a cyano. All right, so it's a 4-cyanobutanoic acid. Over in this position, 1, 2, 3, 4. This is an acid chloride or an acid halide. It is a chloride in this case. So this is a butanoyl chloride. And in the 4 position is a cyano then. So a 4-cyanobutanoyl chloride. So again, we get to trickier compounds. We have to recognize that we have an ester here, and this is a cyano group. The ester, the cyano group is on the acid side, so when we're naming esters, we can kind of cut this ester bond linkage in half. This side with the double bond is considered the acid side. This is the priority side, and then this is the alcohol side, essentially. So this is the alcohol that was used to derive it. And so the name will come from the methyl and then from what's on this side. But recognizing again, the ester is higher priority, the cyano group is no longer part of the carbon chains. That carbon is not part of it. So we only have 2 carbons on this, on the acid side. So this is an ethane, is the highest, the longest carbon chain, and it is an ethanoate. So on this carbon is the cyano group. So this is a cyanoethanoate. And out front then is this methyl group. Note that since this is an ester, there's a space here in between these words. So this is a methyl cyanoethanoate. And the reason why we don't put a number in front of the cyano group is because in this ester group, there's no other position that the cyano could go on. It cannot go on to this C double bond O group here. So it must be on the number 2 carbon, so there is no numbering that's required here. However, if it was a longer chain and the cyano group is further out, we would have to indicate where that numbering is. And if we take a look at the next molecule, then we can see something related to that. So let's say, for example, we have a long carbon chain here. I actually have 2 acid groups. So I've got 1, 2, 3, 4, 5, 6. This is an acid group. This is an acid group. This becomes a cyano group, and we can see it's much easier to name now that it's actually hanging off and not as part of the N group here like this. This carbon comes with it, and it's much easier to kind of name it or to recognize it as its own group in this case. So now the numbering scheme. So if I start 1, 2, 3 from this side, the cyano, it gets a number 3. If I start from this side, 1, 2, 3, 4, the cyano is a 4. So I want the 3 cyano. I want the lower numbering on it. So I'm just going to erase this to kind of make this a little easier to read. So again, I've got 2 acid groups. In the 3 position then is the cyano group. I don't need to put the numbers on the acid groups because it's assumed that they're on the end of the hydrocarbon chain of the parent chain name. So I'm going to say that this is a hexane because it is 6 carbon chain. So it's a hexane dioic acid, and out front is this cyano group. So it's a 3 cyanohexane dioic. The only space is right here when it comes to the separation of the oic and the acid. So again, another example, but I thought this might be a little easier to visualize that cyano group as its own little individual group, where it's harder to recognize when it's part of it seems like it's part of the carbon chain.